Assalamualaikum and good day to everybody. Okay, this is a video on fundamental of testing. I've made this video into two parts. This is the first part. Okay, so just to let you know that this content of our class slides is actually content from um, software testing certification, which is CTFL, Certified Tester Foundation level. Inshallah, if we went through the content together, you can and have done the assignments and practices together. Inshallah, I think you are ready to take for this exam. Okay, this is the first part of the video on the testing fundamental, which will be covering on what is testing, causes of errors, and testing principles. Okay, definition of testing, I think most of you already know, but this is the definition specified in CTFL content. It's actually referring to processes, not only one, consisting of all life cycle activities, okay, from planning, test analysis, test design, test implementation, test execution, and closure. Okay, for both static and dynamic testing. Okay, testing, there are two main types. Static is a testing that you perform without running the code. Okay, dynamic is when the system is running and you actually test the running system, right? And it is concerned with just now the activities, planning, preparing, and evaluating of software quality. So normally this is the purpose, okay, to determine the product specified requirement. I think by now you are used to this, right? So whenever you build such a software, you want to meet the requirement. The same goes with testing, and you want to ensure that by doing testing, you demonstrate that the software is actually fit for the purpose. So if you are achieving both of these, you are actually looking at the quality of the software, whereby when you are doing testing, you are actually trying to detect defects. So when you are doing this, you are actually doing testing. Okay, when you do testing, it's actually related to two things: testing, and actually the second one is related on the quality. Quality is to ensure whatever that you test is actually meeting the specified requirement, and you are actually ensuring that even though there is no more defect in the system is actually fit for the purpose and is fit to be released for the actual use. Right? Testing is necessary because even though you have the best programmer, okay, you have the developer have test all sorts of combination of data, there is still a possibility of defects to occur. Alright, and also not to be confused, like when you are a developer, you are doing coding, right? So you try to fix error, find error. That is actually called debugging. That is a development activity, right? That is not testing. You do that whenever you find error when you are doing development, right? You try to fix everything, right? So debugging is not testing. All right. What are errors? What causes errors? Okay, poor communication. Okay, you got the idea wrong out of when the developer is developing. You might get the wrong information from the system analyst, or maybe the system analyst, when meeting the client to gather the requirement, they wrongly communicate information, making assumption with what the customer say. So maybe they lead to requirement which is um, ambiguous. All right. So errors can also happen because the software complexity. Okay, a very complex system. There's many conditions which not might be understandable by the system analyst when he or she record it. Okay, so maybe it happens because the system analyst is not familiar with that domain, so due to that it does not capture the actual maybe logical or right formula in the requirement. Error also caused by programming error. Okay, changing of requirement. Okay, maybe when they done it for the first time, first version, there is no problem, but later on there are changes in the requirement and it does not fix, it does not change in the codes, and of course error happen because of the time pressure. If you work in the software industry nowadays, a software should be running and be complete within 3 to 4 months, and of course error can also happen because of poorly documented code, right? Because you might take over somebody else's job who left the company and that person write a code in his way, his style, and not following certain template or format. So the person taking over, of course, will be having hard time reading the code, and that might lead to lack of understanding and might cause error to the system. Okay, so when you are testing, this is the uh, flow of effects that you need to observe. Okay, whenever a failure happen on the system, okay, you need to trace back. Okay, what caused it? Right? For example, failure. Let's say this is a banking system. Okay, incorrect amount calculated. Okay, why does that happen? So you need to identify what was the reason. Okay, maybe there is something wrong in the calculation of the formula, and then why does this happen? Okay, the error, maybe the developer is assuming things might not be clear what that is. That developer might assume this might be the formula, maybe because you have done similar kind of system before, and the actual cause is actually because of the unclear requirement written earlier before the development happened. So that's how we go about tackling errors or failure in the system. Okay, right. Whenever a system fail, we go and trace back. Okay, what went wrong? Okay, and then trace back to the original cause. Okay, so this is the flow. You need to be able to remember this: root cause, error, error, defect, defect to failure. Okay, why you do testing? Okay, what is the objective of this testing? Why you do testing? Okay, this is the common reason why you do testing. Okay, to find defects. Okay, that is the main objective. You have a tester to find defects. Let's say you have a tester that could not find defects. Something maybe something wrong with the tester. Maybe it's not competent enough, or maybe the tester does not understand the system. And then it is also done to prevent defect. Okay, of course, when you find it, you can actually prevent it from happening, reduce risk of failure in the operation. Okay, you don't really want this to happen. You don't want to put a system on live and then the system error happen when the user actually use it. Okay, you want to be able to build confidence in the system. Okay, the user of the system, the owner of the system wants to make sure that the system is checked in all aspects before actually running it, before the owner launch it to the system, to the, for example, to the online system. Okay, and test objective is actually to meet contractual, legal, or regulatory requirement. Okay, normally if in a project with the client, they specify that the testing must be done, and if it should be done following what the system owner uh, requires. Okay, so normally they will state it clearly in the contract, so you need to perform it. And at the same time, testing objective is done so that it provides sufficient information, enough information to the stakeholder about the quality of the system and the test. They want to know how good the system is, okay, before they actually launch it. Okay, basically as a tester, these are the testing principles that you need to know. Okay, several all together. Let's have a look at the first one. Testing shows the presence of defect, not the absence. That is what I've mentioned to you just now. Let's say you have a tester and ask that person to test the system, but they could not find any, or maybe there's something wrong. But at the same time, let's say you have done testing, there are so many defects, you identify it again and again and again, you have highlighted it and give it to the developer to fix it. That does not actually prove that the program is defect free. Maybe you find many hundreds, but after everything has been fixed, there is also still a possibility that defects is still there. Okay. Principle 2. Exhaustive testing is impossible. Let's say you are so worried about the quality of the software, you keep on testing it after months and months and months. You have dragged the launching of the system because you are very concerned about to test all combination of inputs. That is actually the ideal situation, but in the actual implementation in the industry, you don't have that much of time. Okay, so you need to be able to scope down the research, the testing. Okay, you need to perform risk analysis because you cannot test for all combination and you don't have the time and you don't have the budget. You have to scope it down. So how you can scope it down, one way of doing it is to by identify what are the risks that worries the client, what are the worries of the client, things that can go wrong. Okay, principle 3, early testing save times and money. I think that is well understood. Yeah, the earlier you test, the better, because if you find the error in the documentation earlier, you can fix that so that it does not ripple, it does not affect the codes and so on. Okay, principle 4 is defects clusters together. So what this means is that normally when you do testing, you find error in one component. Most probably that there will be more error in that component. Why? Because according to the principle of testing, the defect always cluster together. They are always nearby. Okay, principle 5. Beware of the pesticide paradox. What that means is that, if for those who are used to use pesticides on their plants to kill bugs, insects, yeah, after quite some time, the insects and bugs are immune to the pesticide already. Okay, to racun, okay, racun perosak kan. Okay, so the same goes with the testing. So let's say if you have a collection of test cases in your database, you run it for several times on your software that you want to test. After quite some time, you need to update it. Okay, you need to fix it because your set of test cases will no longer be able to detect new defects. Okay, so always need to update it. Don't just, let's say you have a collection of test cases, hundreds of it, you can stay relaxed. Okay, so you need to update your test cases so that it's still relevant to catch new defects. Principle 6 is this is context dependent. Okay, I wrongly spell out this. This is not content, this is context dependent. What it means is that So whenever you want to test a new system, you need to redesign the test cases. Why? Because you are running it for a different system, a different environment, so you cannot simply reuse. Okay, you need to change it to map the new context. Okay, principle 7, absence of error is a fallacy. All right, because I've mentioned to you, as a tester, your job is to find error. Okay, so let's say you run a system and you run the testing and there is no more error and you think that your system is good enough. No, yeah, you don't get yourself wrong. Okay, let's say when you find failures and you fix it, it does not guarantee that the system is actually good enough. Okay, maybe there is no more error. You have fixed everything. Okay, so where at all, but that does not guarantee that you have meet all the expectation of the user, right? Okay, I think that is about the content that I'll be cover for this video. So what we have seen just now, we have seen the definition of testing. Okay, it is actually the purpose is to meet not only for quality purposes, not only for testing, but also to meet quality purposes, which is to meet the user's expectation. Okay, and um, and also testing itself is actually to find defects, yeah. And then we have look at the flow of um, uh, the you have look at the root cause analysis. Okay, whenever you found error, you need to trace back to the original cause of error. And then you have look at 7 principles of testing, right? So let's say if you are the tester, you could not find error, not to be so sure that your system is free of error. Okay, I think that's all for this video. Try to refer to the second part of the video for more information. All right, thank you.